For question 3.4, we need to write a function to initialize timer 2 to generate regular 50 millisecond interrupt and set a global variable e count to 0. The step to do it can be found here in the summary sheet. You should try to understand this block diagram of timer 2. It helps you to make sense of the steps we will be going through when initializing the timer. Before initializing the timer, we need to first calculate the value for the timer so that it produces the desired delay, which is 50 milliseconds in this case. The timer we count based on the clock at this point, and its frequency is the system clock divided by 12. Though the summary sheet shows 24.5 MHz as the system clock, it is just an example. In our case, the system clock is 12 MHz as stated in the question. Hence, the clock that triggered the timer is 1 MHz and the period is 1 microsecond. This means that it takes 1 microsecond to increase one count. To produce 50 milliseconds, we therefore need 50,000 counts. Now, come back to the initialization part. First of all, we need to stop the timer. This is done by clearing TR2 to 0. We also clear the overflow flag by making TF2 to 0 so that it will not prematurely interrupt the CPU before we finish the initialization. Next, we need to put the value into the timer so that it will produce 50 millisecond delay. We have found that value to be 50,000. Since the timer we count up to 0 to produce the interrupt, we need to load the timer with minus 50,000. However, the timer has two separate high and low bytes. So we need to shift the value 8 bit to the right to get a high byte and put it in RCAP 2H and TH2. For the low byte, we just need to mask the high byte using AND operation with 0x00FF before putting it in RCAP 2L and TL2. To allow interrupt, we need to enable timer 2 interrupt by setting ET2 to 1 and enable CPU to receive interrupt by setting EA to 1. Lastly, we start timer 2 by setting TR2 to 1. As required by the question, we need to set the variable e count to 0. So this is the answer for question 3.4.